Okay, so one got a calculator, and to try to simplify these numbers just a little bit. Okay, so first, can you tell me which one of these line segments is longer? 2 pi r or 4 times the square root of pi r?
Looks like from our calculations that this 4 times the square root of pi is longer.
Okay, now here's an interesting question, I think. Could we have figured that out without the calculator? Which is probably what I should have done, but the trouble of doing these things at 6 in the morning. Which one of these numbers do you know already, 2 pi or the square root?
Well, I know 2 pi, it's about 6.2.
Okay, because pi is about what?
3.14.
3.4, and definitely not equal to
5.
Alright, so if pi is about 3.14, can we approximate what the square root of pi is?
Well, it's close to the square root of 3.
Ah, it is close to the square root of 3. Do you know what the square root of 3 is?
The square root of 3, not really.
Okay, well let's see. What do you think the square root of 3 is? What's a number that you think might be a good approximation for the square root of 3?
1.5.
Alright, 1.5. Now you know what 15 squared is, right?
Yeah, it's 225.
So what do you think 1.5 squared is?
2.25.
2.25.
So it's a little small.
Yeah, that's a little small.
Maybe 1.75.
Oh, very good. 1.75 squared. Now, this is a little harder to do in your head, except 1.75 is a fraction. What fraction is
It's
it?
1 3/4.
Or?
Or as a improper fraction,
Yeah.
it would be 7/4.
7/4 squared, which is
49/16.
which is about what?
Well, 16 times 3 is 48.
Haha. So 49/16 is about what?
It's about 3.
About 3.
So it's a pretty good approximation.
Okay, so the square root of pi is about, we could say 1.75 actually, because 49 over 16 is it bigger than 3 or less than 3?
It's a tiny bit less than 3. No, it's a tiny bit bigger than 3. So.
Okay. Let's call this 1.75. You know. Now, 1.75 times 4.
Well, we have 4 plus. That's about 7.
Not 7, because hey, 1.75 is 7/4. So we got pretty close, right? So we
Yeah.
could actually have approximated this, and we should have approximated that. So I sort of did it backwards. Now this side is 6.28 times r, and this side is about 7.09 times r. Okay, which makes this about what 13 and 30 what 13.37.
Yeah. So that's the length of the whole line.
That's the length of the whole line. Now it's all in r though. But in the beginning you didn't know what this line was in terms of r. So do you see what you do here?
We have to find this point, P.
Yeah, we have to find that point P that breaks this line up into 6.28 times r and 7.09 times r.
So
And the whole, what's the length of the whole line?
length of the whole line is 13.37 times r.
Approximately, right?
Yeah.
It's really 2 pi plus 4 times the square root of pi times r. So how would you find where this point is now? I give you the line in the beginning, right?
Yeah.
I say here's the line. I don't tell you it in terms of a radius or anything like that, and you got to find where that point is. Any idea how you would do that?
Oh. Not really.
Okay. How long's the line in the beginning? What would you call it?
Probably about 13.3 maybe?
So in the beginning of the problem, before you knew anything, you
No.
would just call this 13.3?
I'd-
What would you call it?
Well, I'd call it pi r squared. 2 pi r.
Just right in the beginning of the problem, the very beginning of the problem. How long is that line?
It's the line AB.
Yeah.
So
Which is how long? The problem didn't say how long it was.
yeah, so we can just make up a distance.
Call it something.
10.
Call Call it a variable.
Okay, it's x long.
X. Okay, we don't know what it is, so we call it x. Okay, and what did you just find out about x?
That x is about 13.3 times r.
13.37 times the radius. Okay. Now I got to figure out 6.28 times the radius from here. Okay. So I know x is 13.37 about times the radius.
Yeah.
How am I going to figure out what 6.28 times the radius is? How long of a distance that is?
Well, 13 divided by 2 is 6.5.
Okay.
That might help.
Ah, okay. That's an awesome observation. If I cut the line in half, I'm pretty close to the point, but I'm not exactly there. Now, that's a great observation, actually, Sweet. I wasn't going there, but I like that. Which side of the line is that point on? So you said this is about...
So if we cut it in half, P's going to be somewhere over here.
P's going to be over there. Okay, good. How do I figure out it where? Let me give you a simpler problem. Okay, if this line was 5r long, where would 3r be? What would you do?
Well,
I say the line is 5r long and I'm trying to find 3r.
I'd chop it into fifths, then go 3 of those.
Ah, okay. So does that give you a hint on what to do here? It's 13.37 long and you're trying to find 6.28 of it.
Well, it's hard to chop it into 13.37, so that might be, well, 1,337. That's going to be a lot of tiny things.
Okay. Yeah.
And then you have to go 6.28 of them.
Yeah.
628.
That's exactly right. So just divide by 13.37 and multiply by 6.28, and you're going to land approximately right here. Or what you said, chop it into 1,337 pieces, and then find where 628 of them have gone.
Alright.
And there you go. Okay?
Yeah.
Pretty cool, right?
Yep.
Okay. Now we got 2 more things we're going to do.
Okay.